Okay, so in Chapter 5, we're going to focus on linear equations, linear functions, and graphing and writing them. So in order to understand linear equations, we need to first understand rate of change or slope. So I'm going to read the definition of rate of change, and then we're going to talk about how to find the rate of change and see if it's constant for a situation. So you can use ratios to show a relationship between changing quantities, such as vertical and horizontal change. Vertical meaning up and down, horizontal meaning left to right. The rate of change shows the relationship between two changing quantities, two quantities that are changing. When one quantity depends on the other, the following is true. The rate of change is the change in the dependent variable, which is usually a y value, so the change in y, over the change in the independent variable, x, which is usually s, so it's usually x. This is usually, time. Most of the time, when we do a rate of change, time will be on the bottom. The change in time will be on the bottom. So in example 1, I go over an example of rate of change. This table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So in this table, distance is our dependent variable. It depends on our independent variable, time. So the change in distance divided by the change in time is going to be our rate of change. So I'm just going to abbreviate that. Rate of change, ROC. So when I look at this, I look at the change in x. Plus 1, plus 1, plus 1. That's my change in x. My change in y, change in distance, 260 to 250, it's a change of plus 260. 520 to 780, plus 260. 1040 from 780, plus 260. So what I'm doing is I'm comparing the change in y to the change in x. So for each of these, to go from 1 to 2, to go from 260 to 520, it's a constant rate of change. Every time I go up 1 minute, I go up 260 feet. So my rate of change is 260 over 1, or just 260 feet every minute. Okay? So to find my rate of change, mathematically, I could do, and I'll do this in blue, I could do 520 minus 260 over 2 minus 1. The reason I put 520 first is because it comes after 260. I could take any two numbers or any two values and compare them as long as I use, the same ordered pair, okay? So my rate of change is 260. The rate of change in this situation, it is constant, okay? That answers this question. Is the rate of change with respect to time constant? What does the rate of change represent? Well, it represents the speed of marching. The speed. Feet per minute is a speed. So the rate of change represents the speed they were marching at. Okay. In example 2, finding the slope of a line using a graph. So slope, sometimes you will hear the term rise over run. I won't use this a ton. I like to use the change in x versus the change in y because it forces you to think about the variables. So first we decide, look at left to right. Read this line left to right. Is the line going up or down? Well, the line's going up. So my change in y to go from the point on the left to the point on the right, I would go from, in a vertical direction, I would go up 2. So technically my rise is plus 2, okay? My run, read left to right. To go from point to point, left to right, I would go right. 1, 2, 3, 4, 5. So my slope would be my change in y, 2, over my change in x, 5. So that would be my slope. It is positive 2 over 5. So if you really want, this point is negative 3, positive 1. The other point is 2, positive 3. So that's how I get my rise over run. I go to the right, I go up 2, right 5. So that's what I mean by rise over run. Go up or down first, then left to right. Always left to right. But whether your rise goes up or down, that depends on the slope being positive or negative. So moving ahead to the slope formula. The slope formula helps us when we don't have a graph. This part gets a little tricky, so you will get practice with this. So with the slope formula, you have 2 points. You have a point x1, y1, x2, y2. It doesn't matter what x1 and y1 are or x2 and y2 are. The order of the points doesn't really matter. What matters is that you find the slope. And we understand, I'm going to show you in this example, y2, where I get y2. Negative 1 is y2. That makes 4 x2. 3 is y1. 1 is x1. So the first x value, the first y value, the second x value, the second y value. So to get this slope, I'm going to do negative 1 minus 3 over 4 minus 1. y2 minus y1, x2 minus x1. So the slope of this line is negative 4 over 3. And I'm going to ask that you keep slopes as a simplified fraction, okay? Can be an improper fraction like this one where the top is larger than the bottom or the numerator is greater than the denominator. So leave it as a fraction. Simplify it, but leave it as a fraction, right? So in example 4, we're going to find the slopes of horizontal and vertical lines. So we're going to use that slope formula again. So the slope of this line, in this line, y2 is 2. y1 is also 2. x2 is 2. x2 is 2. x1 is negative 3, so 2 minus negative 3. So this becomes 0 over 5, which is actually just 0. So this slope, we would describe this slope as a horizontal slope. And I want you to really make that connection. That horizontal slope is 0 slope. Horizontal lines are lines that go left to right and have no rise, okay? Lines that extend directly left to right. For part B, I'm going to do this in blue just to keep things a little bit separated. The slope of this line, y2 is negative 2, y1 is 1, x2 is negative 2, x1 is also negative 2. So this becomes negative 3 over 0. And if you put in negative 3 over 0 into your calculator, it is not 0. It'll give you an error. We describe this slope as an undefined slope, okay? Undefined slope. That creates a vertical line. So vertical line. And just a quick reminder, a vertical line is a line that goes straight up and down. So remembering when you get 0 or when you get something divided by 0, whether that's horizontal or vertical, that's going to be an important distinction we make later on. So just a quick overview of the slopes of lines. Positive slope, the line goes up from left to right. Negative slope, the slope goes down from left to right. 0 slope is when you have 0 over any number other than 0. That's horizontal slope. Undefined slope is when you have a number other than 0, I guess. It could be 0, but any number over 0, which is undefined. So I want you to write out those things. That should be enough for you to move ahead and do some practice with slope, all right, and be able to work with slope. After this, we're going to talk about something called slope-intercept form. That's graphing actual lines and using the concept of slope to graph lines.